Hi, this is the ME24 Senior Design presentation for the 2025-2026 school year. We will be presenting the SpinSelect Lathe tool.
Modern Industry SpinSelect is a lathe turret tool attachment that includes 5 cutting tool inserts. They currently make 2 versions, one in which the cutting tool is indexed manually by an operator, and one where it's indexed by a CNC machine. Our job was to implement a sensing method to determine which cutting tool is in the active position, which included sensor selection and designing any accompanying mounting on the base of the turret. Here's a quick video of the SpinSelect in action. You can see on the right, it's cutting and then indexing to a new position using the turret's live tooling function.
Moving on to our initial sensing ideas. So some of these different ideas were to have a camera to read numbers etched into the head of SpinSelect. Another was to use an inductive sensor to sense different distances or materials. Third one was have each cutting tool hit a button to track the position as it rotates. And another idea was to sense vibrations from grooves placed around the head.
So getting into the final method that we ended up going with, it was an inductive sensor that will sense different materials under each cutting tool to transmit discrete values collected by the sensor. So you can see we have posts of the different materials right here in green, as well as the sensor right here in red. In this box right here holds a lot of our components like the Arduino Nano and the batteries. And getting into the power saving, the Arduino Nano that controls the system will perform duty cycling to reduce the overall current draw of the system. So when it's actively being used, it will sense for a new position every quarter of a second, and when it's inactive, it will sense for a new signal every 4 seconds. So this will allow the system to run for over 8 months without human intervention or battery changes.
All right, on to some technical analysis. Our final model requires that a chunk is taken out of the base as seen in the picture on the right. And so finite element analysis was performed on both the modified and unmodified SpinSelect. So what this means is we'll perform the FEA on a model with the chunk missing and a model with the chunk still in place. And this is in order to verify the structural integrity of both systems. Only very slight differences were found between the two models, ensuring that taking a chunk out is not going to affect any of the tooling accuracy in the long run.
So on the sensing side of the system verification, we performed numerous tests and analyses, such as sensing at different distances, as well as using different materials to verify the validity of the system.